Hello and welcome to another NGen Math 6 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 5, Lesson 2 on Order of Operations. You've heard of order of operations before, you've definitely worked with it in earlier grades. It becomes more and more important as you move on in mathematics because it really gives us a step-by-step order in which we need to do more complicated calculations. Let's get right into it in the first exercise where we explore a calculation that could work out to be two different things depending on how you interpret the order in which you should do it. So let's get into that right now in exercise number 1. When more than one operation is involved in a calculation, we need to know which one comes first. Exercise number 1. Evaluate the following expression in two ways. So the expression is 10 plus 6 divided by 2. Letter A, I'd like you to add first, then divide. And in letter B, I'd like you to divide first, and then add. And then in letter C, we'll talk about which expression or which is the correct result of this expression and why. All right, so let's just kind of do the calculations together. They're awfully easy. There's no need to pause the video right now. But let's say I added first. In other words, I just kind of read this calculation from left to right, and I said, well, okay, I'm going to do 10 plus 6, right? So, if I added first, let me write down the entire expression. Right? If I added first, I would get, that's not divided by 3, it should be divided by 2. I'd get 16, right? And then I'd divide by 2, and I'd get 8. Right? On the other hand, right, what if I divide first? So again, let me put down the expression, 10 plus 6 divided by 2. So let's say I decided to do this operation first. 6 divided by 2 is 3. Then I did 10 plus 3, and I'd get 13. Now, right away, before we even get to letter C, this illustrates why we need order of operations. All right. Most calculations that occur in the real world have multiple steps in them. They aren't just adding two numbers or multiplying two numbers or subtracting or whatever. They have multiple calculations in them. And I wouldn't want this calculation, to be doing something like, something important, calculating the loads on a bridge or something like that. One case we get 8, one case we get 13. We have to know which one of those is correct. And that's letter C. Which one is correct and why? Pause the video now and see if you can remember. All right. Well, 13 is correct. It's the second one. All right, let me move this out of the way and bring this up. 13. All right, and for the simple reason because division comes before addition in the order. Now you might ask, why is that? And the answer is because we decided it was that way. Like literally. There really isn't much more than that. A decision was made at some point in time. I don't know when. But a decision was made that division and multiplication are, if you will, a little bit higher order than addition and subtraction. So in a calculation that involves all four of the basic operations, addition, subtraction, multiplication, and division, multiplication and division should be done first, from left to right. Once you get those products and those quotients, you should then add and subtract them as well from left to right. So let's take a look at that in the next exercise. All right, apparently not in the next exercise, right? What I want to do actually in the next exercise is I want to talk about a few different ways that we can show products or multiplication. All right, and this is very, very important. From this grade on, you are almost never going to see this symbol used for multiplication, primarily because you're going to be doing more and more algebra. And a lot of times in algebra, we like to use the variable or the letter x. And of course, the letter x and the multiplication symbol are very, very easily confused. So we introduced some new ways of actually showing multiplication. One is with a little dot. It looks like a period, but it's been raised a little bit, so it's not confused with, let's say, a decimal point. But A dot B would be multiply. As well, we can put one of the numbers simply in parentheses and have the other number sitting beside it. Or we could have both numbers sitting in parentheses. But if you see two numbers sitting beside each other, one of which has to be in parentheses, at least one of which, otherwise it looks like a single number. Like if that 8's not in parentheses here, it looks like the number 58. But when the 8 is in parentheses here, it tells us that's 5 times 8. Same thing here, right? We've got these two fractions. That just means 5 halves times 4 sevenths. That's it. So really, exercise number 2 comes down to simply finding some products, which are pretty easy. But we wanted to introduce this problem because we're now going to be showing multiplication almost exclusively using one of these methods. Now, the actual answer to this is simple. As long as we know that 7.2 means 7 times 2, then I'm pretty sure that answer is 14. Right? Likewise, as long as I know 5 with a little 8 sitting beside it in parentheses means multiply, then 5 times 8 is 40. All right? Maybe the hardest part, of course, is if I've got these two fractions, 5 halves times 4 sevenths, right, sitting right beside each other. I know it's multiplication. Maybe if I want it in simplest form, I might do some cross-canceling here, but ultimately, right? Ultimately, what we're getting at here is not how to multiply two fractions. It's to just recognize that what's being asked here is multiplication. All right, so now let's take a look at some additional order of operations work. All right, here we go. So again, recall that when evaluating complex expressions, perform operations within the parentheses first, all right, then multiplication and division going from left to right, and then finally addition and subtraction again going from left to right. So let's take a look at exercise number 3. Using order of operations, find the value of each of the following expressions. Show intermediate steps in your calculations. All right. So what I didn't want to have in letter A is a bunch of multiplication symbols. But what I do certainly have is 9 times 5 and 2 times 7. Without order of operations, maybe I think I should do 5 minus 2 first. But that's not the case. In fact, let's just do this one together. Right, what I should do is look at these two products and say 9 times 5 is 45, and 2 times 7 is 14, and then I should subtract and get 31. All right. Now, in the case of letter B and letter C, we actually have some parentheses where there's actually some calculation going on inside of them. What I'd like you to do now is pause the video and see if you can work through both B and C. I know C might look a little daunting, but see if you can get through them. Again, parentheses first, then multiplication and division, left to right, then addition and subtraction, also left to right. Pause the video now and see what you can do. All right, well, let's go through letter B. The first thing I'm going to do is I'm going to figure out what 8 minus 3 is, and of course that's simple enough. That's just 5. All right. Now you might need to, on the side of your paper, do some of the multiplication and the division longhand. I'm going to do as much of it as possible in my head, keeping in mind what you should have memorized and what you shouldn't. And one thing I should have memorized is what 12 times 5 is, or better yet, what 5 times 12 is. 5 times 12 is 60. Right? So after I do that multiplication, I can now finally do my addition, and my addition is 73. All right, let's do the most complicated one. Now the first thing I'm going to do in this calculation is I'm going to deal with that 12 minus 9. All right, so I'm going to continue to have that 11 times 4 minus 21, but then I'll do, whoops, I lost a division symbol. That would be bad. 12 minus 9 is 3. All right. Now, I'm going to just underline 3 things before we break out and talk about this again. All right, the only thing I did in the calculation so far was I did 12 minus 9 and I got 3. But now what I've underlined are 3 either products or quotients, right? I've got 11 times 4, 21 divided by 3, and 3 times 3. Okay, so I want to do each one of those just kind of doing this one minus this one plus this one. So I've got 11 times 4, which is 44, minus 21 divided by 3, which is 7, plus 3 times 3 is 9. Right, now I can figure out what 44 minus 7 is, and that's 37. Then plus 9 gives me 46. All right, and that's it, right? Not too bad. We just have to be careful. We've got to do our multiplication and our division, then our addition and subtraction. We have one last thing, though, to figure out, which is where do exponents fit into this greater order? Let's try to address that in the next problem, right? So, exercise number 4. Consider the following expression, 5 times 2 raised to the third. Find its value in 2 ways. Letter A, first by multiplying and then by exponentiating. Letter B, first by exponentiating and then by multiplying. Letter C will ask us, did it make a difference? Which one do you think is correct? Of course, if it didn't make a difference, why in the world would I be asking which one do you think is correct? Because then they'd be both correct if they were the same. Anyway, so let's take a look at this together, right? So here we have it, right? 5 times 2 to the third. The question is, should I do 5 times 2, then raise the result to the third, or should I do 2 to the third, get a result, and then multiply by 5? Well, let's see if it even makes a difference. In letter A, first by multiplying, then by exponentiating. So let me write this calculation down again, just so that we've kind of got it here, right? If we're going to first do it by multiplying, the idea would be, all right, I'm going to do 5 times 2, which is 10, and then somehow I'll have, not 13, 13's not in this problem at all, I'll have 10 to the third, which would be 1,000, all right? So that's what I would get if I did the multiplication first. All right. Let's see what happens if I do the exponentiation first. Now, to do the exponentiation first, right, I need to first figure out what 2 to the third is. Now, again, if you've got that memorized, awesome. If you don't, over on the side of your paper, you do 2 times 2, you get 4. Then you do 2 times 4, and you get 8. So that's going to be 5 times 8. And that's going to be 40. Now, let's answer the obvious question. Did it make a difference? Yeah, but we'll just put down yes, right? And the real question is, which one do you think is correct? Pause the video now and just write it down. Is it A or is it B? Well, you might not have a great feel for this, but it's B, all right? So, exponents come before multiplication. And that kind of should make some sense, right? Because really, what does that exponent really say to us, right? The exponent is really saying how many times we should multiply by the number 2, right? There's nothing at all in this that implies that the 5 is being raised to the third power. What this really says is I should do 5 times 2 times 2 times 2. Right? That's what I should do. 5 times 2 times 2 times 2. All right, so I figure out what 2 times 2 times 2 is, and that's 8, and then I do 5 times 8, and I get 40. So, right, exponents then slip in above multiplication and division. Let's take a look at the entire list, all right? Order of operations, all right? Very oftentimes, teachers will abbreviate this as PEMDAS. Some of them will even use the acronym or the memory device, the mnemonic, please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Of course, if you don't have an Aunt Sally, well, then I guess you're in trouble. But what that mnemonic helps you with is remembering that you should do whatever happens in parentheses first, then you should do any exponents that might show up, exponentiation, then multiplication and division, then addition and subtraction. Addition and subtraction, poor addition and subtraction always comes last unless, of course, there's some going on inside of a parentheses. All right, given this order of operations, let's take a look at exercise number 5. Evaluate each of the following expressions using the order of operation. Show intermediate steps. All right, awesome. Let's do letter A and B together and then maybe have you play around with some of these. And I know some of them can be quite challenging on your own. But when I look at letter A, I've got 25 minus 4 squared. See, there's that squaring that we talked about in the last lesson, right? 25 minus 4 squared. And of course, without order of operations, we wouldn't know whether we should square the 4 first, or we should do 25 minus 4, giving 21, and then square it. Luckily for us, it's very straightforward. Exponentiation should come well before addition and subtraction. So the first thing I should do in this problem is I should figure out what 4 squared is. As we know, that's 4 times 4. And that's going to be 16. Once we've figured out that 4 squared is 16 and we've substituted it in, we can now do the subtraction and get 9. Right? That's easy enough. And just like in the last exercise, here I have 5 times 3 squared, right? Exponentiation should come before multiplication, so I shouldn't do 5 times 3 and get 15. I should do 3 squared, which is 9, and then I should do 5 times 9, which is 45. All right, simple enough. Now, of course, I've left the hard ones for you. So pause the video now, work through each one of these things. Again, parentheses, exponents, multiplication, division, addition, subtraction. Pause the video now and take a few minutes to try to get the right answers to each of these expressions. By the way, do you notice how similar C and D are? They give you completely different answers, but they're very similar looking, right? Letter C, I have 5 to the third, or 5 cubed, minus 2 cubed. Here, I've got 5 minus 2, quantity cubed. Now, in this case, I've got to do those exponents before I do the subtraction. And again, if I don't know what 5 cubed is, you know, over on the side of my paper or something, I might do something like this, multiply the first 2 5s, get 25, multiply by 5 again, and I get 125. We just did 2 cubed, so I won't rewrite that out. And then I do 125 minus 8, which gives me 117. Now it's interesting because later on in algebra, you might think that if you had something like this, you could just attach the 3 to the 5 and attach the 3 to the 2, but you certainly can't. 5 minus 2 we have to do first because of order of operations says we should do what's in parentheses before anything else, and 5 minus 2 is obviously 3. And then I have to figure out what 3 to the third is. Again, 3 cubed, we could come over here, do 3 times 3 times 3. Many of these you'll memorize after a while. I'm just doing some now in case you don't know them off the top of your head, but 3 to the third equals 27. So look at what a difference a set of parentheses will make, right? 5 to the third minus 2 to the third versus 5 minus 2 all to the third, 117 versus 27. Now, undoubtedly, the most complicated expression we've got is right here, right? Our order of operations says we should really handle what's in parentheses here, handle what's parentheses in here, then finally do the division. So let's tackle that first one, right? All right, give myself lots of space here. Here, we've got 11 plus 3 squared, which means I really should do that 3 squared first. 3 times 3 is 9. All right. Notice how I'm going to just be very careful. Now, I can also work inside of this parentheses. Now, I know that exponents are supposed to come before multiplication, but I can really do these at the same time because let's be honest, they really are just both multiplication, right? 4 times 10 is 40, and 6 times 6 is 36. Now, of course, I can do 11 plus 9 and get 20. I don't need the parentheses anymore. They're not doing anything at that point once I have that single number. And I'm doing 20 divided by 40 minus 36. I also don't need those parentheses. That's 4. And 20 divided by 4 is equal to 5. All right, nice, simple, beautiful answer. All right, let's look at one last problem and do a little error analysis. Here we go. Exercise number 6. Kirk. Kirk believes the value of the expression 8 divided by 3 squared is 36 because he knows that 18 divided by 3 is 6. Of course it is. And 6 squared is 36. Why is Kirk mistaken? All right. Well, why am I mistaken? You know, I mean, definitely 18 divided by 3 is 6 and 6 squared is 36. So where's my mistake? Pause the video now and see if you can figure it out. All right, well, it's this simple, right? I've made a mistake here because if I've got 18 divided by 3 squared, I must do the squaring first, all right? So the mistake, and I really should have also asked you for the correct answer, but the mistake must do exponent first. don't know if that's the mistake or the solution, but that's the problem, right? The mistake was shouldn't have divided first, must do the exponent first. Now if you actually do the exponent first, right, 3 squared is 9, and then 18 divided by 9 is 2. Look at the difference there, right? The difference between interpreting it as doing the division first, which is very understandable if you did that because you'd be kind of reading it from left to right, right? But the key is, right, you can't do the division first, you got to do the exponent first. All right, giving you a completely different answer. Let's summarize. In a lot of calculations in upper level math, you have to evaluate expressions where there's more than one operation. So when I say one operation, I mean we're just adding, or we're just subtracting, or we're just multiplying, or we're just dividing. You know, all of a sudden we have a calculation where there's, you know, multiplying, dividing, adding, subtracting, exponents, parentheses, lots of different things, and we have to know which one comes first. That last exercise might illustrate it better than any other one we did today, right? Getting an answer of 36 versus getting an answer of 2, right? Huge difference there. It is really important for you to work on these, you know, to not use a calculator, to just kind of work through them step by step so that you understand, and when you look at an expression, you can immediately know what are the first things to be evaluated and what are the last things. For now, I just want to thank you for joining me for another NGen Math 6th lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.